Hi everyone. In this video, we'll discuss how to rotate a linked list. So we are given the head of a linked list. We need to rotate the list to right by k places. Let's take few examples. So we are given this linked list and we need to rotate it to the right by one place. So if we rotate this linked list to right, then basically G will come at the first position. So the output will be G A B C D E F. So the last node, which is G, will come at the first because we are rotating the linked list to the right. Let's take one more example. So now we need to rotate the linked list to right by 4 places. So K is 4 here. So for K equal to 1, G will come first and the linked list will be G A B C D E F. For K equal to 2, F will come, then F G A B C D E. For k equal to 3, E will come at head, and for k equal to 4, D will come at head. So the output for this will be D E F G A B C. Let's take one more example. So now k is 7. So for k is 4, we have this linked list which has head at D. So for k equal to 5, the linked list becomes C D E F G A B. For k equal to 6, B will come at the head. So it becomes B C E D E F G A. For k equal to 7, A will again come at first. So the linked list becomes A B C D E F G. So this is our starting linked list. So if we move this linked list right by 7 places, we get the same linked list back. So this is because the length of this linked list is also 7. So there are 7 number of nodes in this linked list. So if we rotate the linked list by 7 places, we'll get back the original linked list. Now what if k is greater than length of the linked list? So in this example, k is 12. So we know that if k is equal to the multiple of length of the linked list, then we'll get the same linked list back. So what we can do is we can divide 12 by length of the linked list and we can find the remainder. So in this case, the remainder is 5. So we just need to rotate this linked list by 5 places. So the output for this will be CDEFGAB, which we have also found here. So if k is greater than the length of the linked list, we can simply divide it by the length and shift by the remainder that we are left with. So these are all the possible cases that could be there to rotate the list. So once we've understood the problem statement, let's look at the algorithm. So we are given this linked list and a digit k by which we have to rotate this to the right. So let's say for the first example, we have k equal to 4. So because when we rotate the linked list, the last nodes will come at the first. So the first step that we have to do here is we need to connect the last node to the head of the linked list so as to form a cycle. So that when we move by right, we have a connection from the last node. And once we find the new head of the linked list, we'll break this cycle. So the first step is we need to connect the last node with the first node. So to do that, we need to find the last node. Let's say we have a pointer node which is pointing to the last node of the linked list. And we need to find the length of the linked list also. So length of the linked list is 7 here because there are 7 number of nodes. So the first step which we can say is connect last node to head. So in the second step, we need to move the last node by length minus k nodes. So length is 7, length minus k is 3 nodes. So from G we need to move by 3 nodes. So A is 1 node, B is 2, C is 3. So node will come at C. So once we have the node at C, so the next of node will be the new head. So D will become the head and we'll break the link from C to D because C will be the last node for this rotated linked list. So in the third step, make head equal to node next and make node next equal to null. So basically we made D as the new head and we break the link from C to D because C will be our new last node. So we print this linked list now. So it will be D, E, F, G, A, B and C. So this is the linked list when we rotate it by 4 number of places to the right. So if we just write the steps in the algorithm. So let's say we have this function rotate right, which takes two parameters, head of the linked list and the digit k by which we have to rotate the linked list to the right. So first we have to find out what is the last node of the linked list and the length of the linked list. So let's say we have a function find last node which gives us these two values. So we just need to traverse from the head of the linked list until the head becomes null. So this function find last node gives us two values. So for this case it will give us g comma 7 because there are 7 nodes in the linked list and g is the last node. Then we need to connect the last node with the first node. So we are doing node next equal to head. So we are connecting last node G to the head of the linked list A. Then we divide K by the length and we find out the remainder. So it is because if K is greater than length of the linked list, let's say K is equal to 13. So we know that after 7 places to the right, because 7 is equal to length of the linked list, we'll get the original linked list back. So we just need to rotate it by the remainder that we are left with. And then we move the last node by length minus k nodes. So last node was at G, so node pointer was at G. So now we move the node pointer by length minus k. So length is 7. For this example, k we took as 4. So we move this by 7 minus 4, which is 3 nodes. So 3 nodes means it will come at C. Then we make head equal to node next. So head will come at D. And then we make node next equal to null. So we break the link from C to D. And then we return the head of the linked list. So we return the pointer to D. So this will give us the linked list D, E, F, G, A, B and C. So if we rotate the linked list by 4, we'll get this linked list. Now let's take one more example when k is equal to 12. So now at this step, k will be 12 modulo 7, which is the length of the linked list. So 12 modulo 7 will give us 5. So now we come in this for loop and we move node by length minus k nodes. So length is 7 and k is 5. So we move node by 2 nodes. So when we move node by 2 nodes, we come at B. So node will come at B. And in the next step, we make head equal to node next. So head will come at C. And then we break the link between node and head. So we make node next equal to null. So we are breaking the link from B to C. And we return the pointer to head, which is at C. So the linked list becomes C, D, E, F, G, A and B. So if we rotate the linked list to right by 12 places, we'll get this linked list. So now once we've understood the algorithm, let's have a look at the implementation. All the source code that I'll be showing is available in my GitHub repository, link of which is present here and as well as in the description. Now let's have a look at the code. So in the main function, I first create the linked list. Then I call this function rotate linked list and I pass it head and a value k. So I've passed 4 values of k which are 1, 4, 7 and 12. Let's see the function rotate linked list. So in this function, first I check if the head is null or if k is equal to 0. If that is the case, I just return head. Then I call this function find last node. So this function gives me the last node of the linked list and also gives me the count of the number of nodes which are in the linked list. So in this function you can see I just iterate the linked list and I find out the last node and the length of the linked list. Then I join the last node with the head of the linked list, so I create a loop. Then I handle the case when k is greater than length of the linked list, so I divide k by length. And then I move node by length minus k nodes. So I have this for loop in which I move node by length minus k nodes. So now node is at the last node of the linked list. So I make head equal to node next and I make node next equal to null. And then I return the pointer to the head. Now let's see the output of this program. So the original linked list was A, B, C, D, E, F, G. When we rotate the linked list by 1, we get the linked list starting from G. When we rotate it by 4, we get starting from D. When I rotate by 7, we get the original linked list back because 7 is also the length of the linked list. And when I rotate it by 12, we get the linked list starting at C. So this problem is also available on Lead Code as question number 61, rotate list. I've pasted the same code here and it is success. So that was all for this video. If you have any doubts or suggestions, please leave in the comment section below. If you like my content, please do like, share and subscribe to my channel. It really motivates me to make more such content. And until next time, this is Sandeep Thapar signing off.